Hello everybody, this is Iftikhar Ahmed and you're watching my channel Physics by Iftikhar. Now, in this course, the first chapter that we have is Electric Charge and Field. So this chapter is a part of a branch of physics that is the electricity and magnetism. So electricity and magnetism is so much important, and it is having a lot of application in our daily life. There are a lot of natural phenomena you can explain with the help of this branch of physics, and with the help of this electricity and magnetism we have so many devices like laptop, cell phone. Almost all electrical devices would not have worked without knowing the without discovering this particular branch of physics, that is electricity and magnetism. And the same thing, like this particular branch is also responsible, this electricity and magnetism is also responsible for so many natural phenomena. For example, the lightning is happening due to electricity. This branch of physics is so much important, and it is having a lot of interesting phenomena in it. The first chapter in this electricity and magnetism is electric charge and field. So the first question that comes in here is, so before starting this, is what is a electric charge? And how we got to know that in this universe there is a thing called charge is existing? How do we got to know, how we discovered that charges are there in this universe? So for that purpose, we have to ask the other question. So this is how the theory, this is how the discovery of a new theory begins, with a question. So the question here is, what are we made up of? What are this stuff around made up of? So we know from the ancients that these stuff around us, everything in the universe is made up of molecules. How do they got to know, how do they conclude that everything is made up of some tiny thing called molecule and we are all made up of that? Because if you to get the feeling for it, suppose I have some stuff, some particle, some kind of stuff, a mass. If I break it into two pieces, I'll get half of it. If I break it again, I'll get quarter of it. If I break it continuously like this, so I'll get a particular state on which I can't break that substance. So that is the finest thing of, that is the finest part of a substance which you can't further break, and that is called the atom. That is called the atom. You can't further divide it into two pieces. That is called the atom. And again, one more question. What are atoms made of? This process goes on like this only. That's how, by questioning ourselves, we discover new things in physics. So the question here is, what are atoms made of? Today, what are atoms made up of? Atom is made up of electron, proton, and neutron. These three are the fundamental elementary particles which are responsible for the stuff around us. Everything in the universe is made up of these three fundamental particles: electron, neutron, and proton. There are other particles are also there, like photon, alpha particle, gamma particle, and but these three are the fundamental particles. Okay, so these three particles are having masses. The mass of the electron is 9.1 into 10 power minus 31 kg, and the mass of proton is 1.672 into 10 power minus 27 kg, and the mass of neutron is 1.674 into 10 power minus 27 kg. Now the mass of proton and mass of the neutron are almost same. Okay, now whatever stuff we have around us, everything in the universe is made up of these three fundamental elementary particles: electron, proton, and neutron. There are few other particles are also there. Photon, for example, alpha particle, gamma particle, other particles are also there, but these three are the fundamental particles with which all this stuff around us is made up of. Now, using these three fundamental particles, we are going to perform some experiments. So these experiments will explain you, will try to help you understand how we discovered the charge, the electric charge, how we got to know that there is a thing in this universe called charge. So let's start. So this is a thought experiment. Whatever I say, you have to imagine those things. So physics is all about imagination. If you have nice imagination, if you have a good imagination, with your imagination you can answer. So, see, without knowing the laws, you can, by just using your common sense, you can give the right answers. Okay, whatever I say, try to imagine, try to get the picture of it. So suppose I have two electrons separated by 1 centimeter distance apart. Okay, clear? Now we know, so they both have the same mass. It's not like one more thing that I want to clear is, if you're saying electron will have this much mass, any electron, if you bring it from any part of the universe, bring that electron and take electron from my room, all the electrons, they all will have identical mass. Okay, it is not like one electron is having some mass and the other electron is having some other mass. They all will be identical. They will have equal amount of masses. If it is having some kind of a size and shape, then it will have the exactly same size and shape. Okay, so now these two electrons are there and they are having distance between them 1 centimeter. Now we have studied in first year that if any two objects are there and if they have masses and they are separated by some distance, they will exert a gravitational force between them, and that gravitational force is directly proportional to their masses and inversely proportional to the square of the distance between them. So here there will be a gravitational force, that is G is equals that is F sub G. This sub G stands for gravitational force. G, that is the universal gravitational constant, mass of one electron, mass of the other electron divided by the distance between them square. So this expression will give you how much is the attractive force between these two electrons. And by seeing the expression, you can say that more the mass, more the force of attraction will be there between the electrons. It is not like by seeing the formula we got to know that they will exert more force on each other. I think we are coming in a wrong way. Actually, how we discovered this formula? First, we have seen experimentally that if we increase the masses, the force is increasing between them. So that's why we have written force is directly proportional to m1, m2, like that. And one more thing we have noticed with the experiment, that after the experiment we are writing this expression. Okay, it is not like because of this expression they are working like that. Actually, because they are working like that, we have this expression. So what we have noticed from the experiment is that if you increase this distance by 2 amount, the force is decreasing by 4 amount. If you decrease the distance by 4 amount, the force will get increased by 16 amount. So there is some kind of pattern between, there is some kind of relation between the force, the attraction force between these two electrons and the distance between them. So it turns out that they are following the inverse square law. This is called inverse square law. It's a lot of importance in physics. This concept, this inverse square law, you'll see almost everywhere in physics. Okay, so not just the equation, you have to get the feeling for it. Not just the equation, you have to get the feeling for it. The equation is just about 1 inch, but there is a lot of meaning, there is a lot of theory is there behind it. What this equation is telling us, if you increase the distance by 2 amount, the force will get decreased by 4 amount. If you increase the distance by 4, the force will decrease by 16. So this is the pattern we have seen from the experiment, and after the experiment we came up with this expression and this expression. And to remove the proportionality, we have taken a constant called universal gravitational constant. Now, according to this theory, according to this law of gravitation, what should happen here in this scenario? According to this law, we should see attraction between these two electrons. we should see attraction between these two electrons according to this law, and we are 100% sure about this law because this law is experimentally, theoretically well proved, okay, given by Sir Isaac Newton. Now, but what actually we are seeing here is repulsion. They are not coming close to each other. These electrons are not coming close to each other, but they are trying to go away from each other. Well, something strange is happening. We are expecting something, but that is not what happening in the experiments. In the experiment, according to this law, the two particles should attract, but they are repelling each other. So the force of attraction between these two masses should be 5.5 into 10 power minus 67 Newton. Actually, this much should be the force of attraction between them. But these two electrons are getting repelled with a force 2.3 into 10 power 24 newtons. Strange. So, if something is not happening according to the if something is not happening according to what we have expected, it means there is some physical phenomena, there is some hidden property that we are not taking into account. That's why we are unable to explain this experimental results. So what we are not taking into account. So this force, we name it as electric force. How this force is coming? Due to what property of matter this force is coming into picture? See, like mass. Mass is responsible for the gravitational force. So there should be something which is giving you this force, electric force. So what is that property? See, this property, the property of mass is giving you the gravitational force. So there should be some other property also present in the electron which is giving out the electric force. So that property is the charge. That is what? That is the charge of the electron. This is how we got to know about charge. So because of charge, the electric force is there. And now one more thing we can notice here, that is the gravitational force is way small as compared to the electric force. Even a small amount of electric force can create even a small amount of electric charge can create a huge electric force. Even a small amount of electric charge can dominate a huge mass gravitational force. You see, this number is so much bigger as compared to this number. This thing. So to give you the feeling for it that the electric force is big as compared to the gravitational force, let's do an experiment. Suppose I have some piece of papers over there on the table. Okay, some piece of papers are there on the table, and I have a comb. Before combing my hair, what I'm doing, I'm bringing my comb near to these pieces of paper. You won't see anything. Nothing is there. The papers are not at all moving, not at all coming near to the comb. But the moment I comb my hair, now after combing my hair, what I'm doing, again same. I'm bringing this comb near to these papers, this piece of papers. So now what is happening is some strange phenomena. So these papers are getting lifted up towards the comb. And what is the reason behind this thing? Means what is actually happening inside the piece of paper and what I have created by combing the hair in a comb. I'll explain, you will get to know in other classes. But for now on, you see the whole earth, this much mass is having. This much mass is trying to bring these piece of paper towards it. And that is the force of gravitation. But with a small electric force that you have, which you have created by just combing your hair, is enough to cancel out this force. You see, you are, by just a small comb is enough to cancel the whole gravitational force of the earth. You see, at the same time, the piece of papers are trying to go downward, but the comb's electric force, this force, what you know, the force due to which these papers are getting near to the comb is due to electric force. So that's how you can get the feeling how big is electric force as compared to the gravitational force. You're getting my point? Now, we will do the same experiment with protons also. Let's take two protons. I have two protons separated by 1 centimeter apart. The gravitational force of attraction between them will be, so this expression will give you some force, and according to this law will tell you that there will be attraction between these two protons because of their masses. But what we have seen, what we have observed experimentally is completely different. What we are actually seeing is the repulsion between these two protons. Same question again. Why the protons are getting repelled by each other? There is a gravitational force between them, but what is that force which is way bigger than the gravitational force of attraction? And it is cancelling, that force is cancelling out this attraction and trying to take these two protons away from each other. Where that force is coming? From where that force is coming? Okay, so that force, same here also, that force is having the magnitude 2.3 into 10 power minus 24 newtons. With this force, these two protons are trying to move away from each other. It means repelling each other. We have expected them to come closer to each other, them to attract each other, but that is not happening. Now, you see, same. Mass is responsible for the gravitational force. Something should be responsible for this electric force. The same thing is that this force of electricity is coming because of the charge. It means protons are also having charge. And one more thing that you can conclude from here is that whatever the charge of proton is there, the same amount of charge the electrons are having. How come you are saying that? Because the force of repulsion is same in both the cases. If same amount of charges will be there, the repulsion force will be same. Now let's find out whether the neutrons are having charge or not. Same experiment. Take two protons, not protons, the neutrons, two neutrons apart from 1 centimeter apart from each other. So because the protons are having mass, they will also have some gravitational force between them. Gravitational force, and that gravitational force is what? The attractive force it is. So we expect them to attract each other. According to the law of gravitation, the two neutrons should attract each other. So now the question is, what we have seen experimentally, whether they are attracting each other or not, repelling each other. So what we have seen experimentally is they are attracting each other indeed. There is no any repulsion force between these two neutrons which are 1 centimeter apart. So this is how we got to know that neutrons does not have any charge. Why? Because there is no repulsion between them and there is an attraction between them, and that attraction force is exactly coming out to be equal to the gravitational force. So that's how we know neutrons are neutral, proton and electrons are having charge. but yet we don't know whether the proton and neutrons are having the same kind of charge or different kind of charge. Based on these experiments, we can't say that the protons and neutrons are having different charge polarity. Now, in our next class, we will be discussing about what kind of charges do we have in nature. The charges can have only a single kind, or two kind of charges will be there, or three kind. Let's find out in the next lecture. Okay, so stay tuned till then. Thank you so much for watching.